Hello learners, Mr. G here. I'm going to make another video regarding Newton's law or application of Newton's law of motion. Still have to apologize about my voice, but I think the topic is difficult and it's important, so I'm going to do it anyway. So let's go to this question. This question is a good question. It was in a question paper of previous years. I don't really remember what year, but it was in different question papers. The question says two blocks A with mass of 3 kilograms and B with mass of 2 kilograms of the same materials are connected by light inelastic rope. A force of 12 Newton is acting on block A at an angle of 60 degrees to the horizontal as shown below. The kinetic coefficient of friction between the blocks and the surface is 0,10. Here is the picture of the situation of what is happening. You have the applied force of 12 Newton, the angle of that force between the angle and the horizontal is 60 degrees, and the masses of the object. Okay? Question 2.1, draw a free body diagram for block A. Now, that is 5 marks for that. Let's draw the free body diagram. Okay? Now note, this free body diagrams is for marks, so we cannot draw the axis, we cannot draw the components. Okay? So let's write here, we sort out this number here, and write here solution. Solutions. 2.1, the free body diagram for block A. So this is block A. What forces are acting on that block? Well, on that block there is acting the applied force, which forms an angle. This is the applied force. There is normal force. There is normal force. There is weight. There is frictional force, which is in the opposite direction of motion. And there is also tension. This is tension force, which is the force on the rope. Remember this, block B is actually pulling backward object A or block A. Okay, so here you can see the forces, and then you will get 1 mark per force. Note the following. In this question, when you've been asked to draw the free body diagram, you cannot draw the components, otherwise it will be taken as an extra force and you will lose 1 mark. So only the actual forces acting on the block. Okay, now that is 2.1. Let's go to question 2.2. Question 2.2. Let's go to question 2.2. Said calculate the magnitude of the horizontal component of the applied force. Now this applied force, now we're going to draw a new free body diagram, but this one will have everything. Okay, in this one we will have the axis, you will have the component, and this one will be used for later for the other question. Okay, so let me redraw the same one as question 2.1, and then from there we'll take it. Just give me a minute. Okay, here we have the free body diagram. Is exactly the same one like we drew before, but now in this one we are going to add the components. So here you will have the applied force in the x-axis. This here is the applied force in the x-axis. This angle is equal to 60 degrees. So how do you calculate applied force in x? This will be equal to the adjacent side times cos. So here will be applied force multiplied by cos 60 degrees. This is a way to calculate the component in the x direction. And if you take it to the y-axis and you determine the components, here you will have the applied force in the y-axis, which is equal to the applied force multiplied by sine of 60 degrees. Later on you are going to need these components. Okay, Now, in question 2.2, they're just asking you to calculate the magnitude of the horizontal component of the applied force. In other words, they want to know the applied force in X. So, if we substitute here, we have that the applied force is equal to 12 Newton. It is given there. It is equal to 12 Newton multiplied by cosine of 60 degree. And when you do calculate, you have the answer is going to be 6 Newton. 6 Newton. So that is the horizontal component of the applied force. Okay, this question was having 3 marks. So the marks will be 1 for writing the formula, 1 for writing this one here, 1 for the substitution, 1 for the answer. Those are the 3 marks. Okay, so let's go to question 2.3. Question 2.3 say, state Newton's first law of motion in what? Right, 2.3. 2.3. Now, this law states that an object remain or stay, remain at rest or moving with constant velocity. And the word constant velocity means same speed or constant speed in straight line. That is the meaning of constant velocity. So an object remains at rest or moving with constant velocity unless it is acted upon by an unbalanced net force. Alright, that is Newton's first law. So an object will remain at rest or moving with constant velocity unless it is acted upon by an unbalanced net force. The formula for that law, remember, is net force is equal to 0. And when the net force is equal to 0, is because the object is either at rest or is moving with constant velocity. So there are 2 marks for that definition. Alright, if you state the definition correct, you will get 2 marks. Okay, so let's go to question 2.4. Question 2.4, they say calculate the normal force for block A. So here we have the free body diagram for block A. We're going to still use the same free body diagram because this one was done for us to work. Okay, so here the normal force is in the y-axis. So we are going to be working with the y-axis. This here is the y-axis. Okay, and what we know, the object is at equilibrium in the y-axis. So in the y-axis, we are going to use Newton's first law. Okay, what is Newton's first law state? In y-axis. What do we have? Net force is equal to 0. What forces do we have in the y-axis? Normal force, applied force in y, and weight. So we have normal force plus the applied force in the y-axis minus weight is equal to 0. If we rearrange this one, normal force will be equal to weight minus applied force in the y-axis. And the applied force in the y-axis, the formula is here in the same axis that you can see it. So it is equal to weight, which is mass multiplied by acceleration due to gravity minus applied force sine 60 degree. If you want, you can calculate these questions separated. For example, you come here and you calculate weight is equal to mg. This is equal to, for block A, the mass was 3, so it's 3 times 9,8, and that is equal to 29,4. Okay, and then here for the applied force in y, you can calculate it separated as well. We have that applied force in the y-axis is equal to the applied force multiplied by sine 60 degree. This is equal to 12 multiplied by sine 60 degree, and that is equal to 10,39. 10,39 Newton. Now you may substitute those numbers there in the equation, and we have the normal is equal to 29,4 minus 10,39. When you do the calculation, you get that the answer is 19,01 Newton. This here is the answer for normal force. Now, the marks that you will get there are as following. There is 4 marks, so you will get 1 mark for either of these one. For any of them, you will get 1 mark. Alright? Then you will get 1 mark for this calculation, 1 mark for this calculation or the substitution, and 1 mark for the final answer, and that is a total of 4 marks. Okay? I hope it's clear. Let's go to question 2.5. Question 2.5. Now question 2.5 says, state Newton's second law of motion in words. Okay? So I'm going to quickly write Newton's second law of motion in words, and then I'll be back with you. Okay, here we are with the Newton's second law. Now this law says when a net force acts on an object, the object will accelerate in the direction of the net force. The acceleration is directly proportional to the net force. These parts here carry the first mark. The acceleration is directly proportional to the net force, and the acceleration is inversely proportional to the mass of the object that carries the second mark. These 2 marks for this definition. Let's go to question 2.6. Now question 2.6 is a tricky one here. Question 2.6 said, calculate the magnitude of the acceleration of the block. So to do this, we have to work with both blocks. So you are going to write on one side block A, and on the other half of the paper or the page you're going to write block B. So, and you are going to work separated for each block. For block A, we already have the free body diagram. It's drawn here, so we don't have to redraw it. Now, in what axis are we going to work? We are going to work in the x-axis. Here is the x-axis. Okay? So we come in here. We're coming here, and we starting with Newton's second law. F net is equal to ma. We're working in x-axis. What forces are acting there is in the free body diagram. Okay, let's go and show you again. We have the applied force in the x-axis, we have the frictional force and we have the tension. And then to the right is positive because the object is moving to the right. So here is the applied force in x minus frictional force minus tension is equal to MA. Now, what is the problem here? We don't have friction. We don't have friction. We have to get friction first. How do you get friction? Friction is equal to kinetic coefficient of friction multiplied by normal. Here, this is equal to 0,1. It is given to you the coefficient of friction. There you go. Here is the coefficient of friction, 0,1. So you go there, 0,1 multiplied by the normal, which was calculated in question 2.4. 2.4, the normal for block A is 19,01. So this is 19,01. Frictional force is equal to 1,901 Newton. So now we can go and substitute the applied force in X. We also did calculate it in the first question. In the second question 2.2, which was 6. So if we substitute here the values we have 6. Remember, it was calculated in question 2.2. Frictional force is 1,901 minus T, we don't know T, and the mass is equal to, I don't remember, the mass is equal to 3, so it's equal to 3A. Here we can get this calculation here, there, done, and this gives 4,099. Please, you can check all the calculations, okay? Make sure the calculations are well done. Now, here we have two unknown. We don't have tension and we don't have acceleration. So we're going to stop there and we're going to call this one equation 1. Alright? So now we're going for block B. Now for block B, we have to do the free body diagram. Okay? So let's do the free body diagram for block B. Alright? Let me just draw the axis and I'll be back with you just now. Okay. We're back. For block B, here, for block B, let's go to the picture. What do we have for block B? We have the tension. This tension is being pulled there. This tension is being pulled there. This is T and it's the same T. Alright, that is T. We have the tension to the right. We have the frictional force to the left, normal and weight. So this is tension. You have friction to the left. You have weight and you have normal force. Those are the forces acting for block B. Okay? Now, we're going to apply Newton's second law the same way as we did with block A. So, Newton's second law, net force is equal to MA. I'm going to be working in x-axis. What forces are acting in the x-axis? Then we have tension, which is positive, minus frictional force, which is negative, is equal to MA. Now, what is the problem? Similar to before, we don't have the frictional force here. Now, frictional force, same formula, kinetic coefficient of friction multiplied by normal. But there's still more problems. We don't have the normal. The normal for a B. So, to calculate normal, remember you have to go to Newton's first law. So, F net is equal to 0. You have normal minus weight is equal to 0. Normal is equal to weight, which is equal to mg, which is equal 2, let's substitute the mass was 2, I think, I'm not sure, it's 2, so it's 2 times 9,8, the normal is equal to 19,6 Newton. This number is now going there, so we can calculate the friction. So remember, what we're looking for is actually friction right now. So let's substitute there for friction. Let's write it here in this small corner. Friction is equal to 0,1 is the same number because it is done of the same material, multiplied by 19,6, and the frictional force here is going to be 1,96 Newton. So now we may come here back to the Newton's second law and substitute. Alright, so I'm going to write this one right there. We have T minus frictional force is equal to MA. Then the T, we don't know it. Frictional force was calculated right now here at the bottom. It is 1,96 is equal to 2A. We have 2 unknown, and we're going to call this one equation 2. Now we are going to add the 2 equations. So I'm going to add equation 1 plus equation 2. Equation 1 plus 2. How do I add? But this is mathematical method. You can use any method you feel more comfortable with. So I'm going to add everything that is on the left hand side. I'm going to add this one plus this one, left hand side, and therefore I will have 4,099 minus T, and I'm going to add what is at the bottom, plus T minus 1,96 equal to, and I'm going to add everything that I have on the right hand side, and that will be this side here. I'm going to add this one and this one. So it will be 3A plus 2A. And then I'm going to add these two numbers. T minus T will cancel each other, and then what will we have here? So we have 2,139 is equal to 5A. So A is equal to 3,29 divided by 5, which the answer is 0,4278, 0,43 meters per second square. Okay, so that is the answer for acceleration. Now, this is five marks for this. It appeared to be a lot of work for only 5 marks. So you get 1 mark for writing the Newton's second law in either side, either for A or for B. You get 1 mark for arriving to equation 1, 1 mark for arriving to equation 2. There is 3 marks. 1 mark for the substitution of one of these numbers here, either this side or this side here, and 1 mark for the final answer. Those are 5 marks. It's a lot of work, you get little marks, okay? And then, just to finish this question, it's been a little bit long, just to finish it, they say calculate the tension T in the rope connecting the 2 blocks. So all you have to do is to substitute the acceleration in either equation 1 or equation 2. This is question 2.7. Question 2.7. So you either substitute acceleration in equation 1 or equation 2, and you will get the same answer. I'm going to use equation 2. We have T minus 1,96 is equal to 2A. equal to 2a. And we are going to substitute the acceleration. We have t minus 1,96 is equal to 2, and you are going to substitute a there, which is 0,43, and then the answer for tension, when you do the calculation, is very simple calculations here, you will get 2,82. Alright, and this is all for now. The marking for that question is 2 marks, so 1 for the substitution of the A, 1 for the substitution of the A here, and 1 for the final answer. Is 2 marks. So that is all for now. This question, if you follow the steps, it doesn't matter what question they will ask you, you will be able to do it. Alright, thank you very much. Good luck, and I'll see you next time. I hope my voice is much better next time. Thank you.